Hope guys, my voice is audible for you. Yes, fine. It was like a small technical error, guys. So we rectified that. So I hope you join with us. Is it audible for you? Yes. Is it audible? Okay, fine. Good. Thank you. Thank you for your response. So we are at the development, differentiation, de-differentiation, and redifferentiation. You ask a question like only with the meristematic tissue. It's not only the meristematic tissue, it's with the anything like you can take parenchyma, you take like sclerenchyma, you take in any specialized structures that you can. Just I gave an example that is parenchyma. You take even sclerenchyma, you take collenchyma, any type of cells that you can take. Now what happens? This specialized structures which lost their ability, and again it start forming a new type of tissues called meristematic tissue. This we call it as a de-differentiation. So as far as development is concerned, differentiation, de-differentiation, and we have a re-differentiation. Now we move on. The next part is plasticity. So you asked for the plasticity. Here we go. The plasticity. I go with the plasticity. Coming to the plasticity, yes. This is actually the slide which I took for plasticity. Okay. And you asked for like, if you guys asked for the taxonomy and the plant, the kingdom and everything. I mean the animal, sorry, the plant kingdom you talk about. Maybe you start the next chapter. Much like comfortable with that chapter, the taxonomy. We'll start next chapter. I mean, next week we'll start with the taxonomy because if you guys requested for taxonomy, so we'll start with the next chapter, the taxonomy also. Okay, fine. Coming to the plasticity part. Plasticity is actually what do you mean by plasticity? This is the part which shows plasticity. Plasticity. So what is plasticity? Plasticity is the different pathways as a result of varying environmental conditions. The plants which goes a different pathways which goes based on the different environmental conditions. Like the environmental factor, the extrinsic factor will be the determinant the factors here, which determine the shape of the leaves, especially. For example, the ability of the plant to modify its development due to the intrinsic and the extrinsic factor. So this is called as plasticity. So definition for a plasticity: the ability of a plant to modify its development due to its intrinsic or by the extrinsic factor. This is called as plasticity. Okay, this may be because of intrinsic or maybe the extrinsic factor. For example, you take, this is the case, you take there are phases that you see: juvenile phase, adult phase, the different phases that you could see. For example, in the environmental plasticity that you take, there are two types of plasticity: intrinsic plasticity and extrinsic plasticity. Okay, so totipotency will not be discussing under the totipotency. We have like the other chapter, the biotechnology part, the tissue culture. In the tissue culture, we discussed about the totipotency. The tissue culture area only we discussed about totipotency, not in this part. Okay, fine. And coming to this part, you take an example like a buttercup. Then you take a Ranunculus fragillaris. Buttercup, CUP, buttercup. Okay. In this examples, you take buttercup and you can take Ranunculus fragillaris. You take in the coriander especially, you could see, yeah. Juvenile phase, you could see, what is the juvenile phase? Can someone tell me what is? Because the phases, when you see in the pattern of the plants, you could see juvenile phase, vegetative phase, senescence phase. This you would have studied. Definitely, you might be knowing what is the juvenile phase and what is the senescence phase. Fine. When you talk about this juvenile phase and adult phase and the terrestrial habitat, the early stage, you could see this is how actually the structure of the leaves look like in the juvenile phase. Then you go to the adult, this is how the plasticity, the structures got changed. And coming to the terrestrial habitat, when the same plants going the terrestrial habitat, the structure has been modified in this case. And this we call it as an heterophyly. This we call it as heterophyly. Okay. But heterophyly, this different forms of leaves of the same plant. We're not talking about the different plants. We're talking about different forms actually that you could see of the same plant. Not talking about the different plant. These different forms which occur in the same plant, but the conditions are different. Different intrinsic and extrinsic condition, that is heterophyly. This plant shows like manipulation with this, right? With this And you could see this type of manipulations. This we call it as an heterophyly. Okay, you could say examples you take in case of buttercap and Ranunculus fragillaris. This process we call pathways. The plants which takes the different pathways. This we call it as a plasticity or heterophyly. You could see the plants how like the structure is getting varied, like in juvenile phase. Juvenile phase in case of the senescence phase, in case of adult phase, like senescence is something like death phase that we're talking about, where like withering of leaves and all the process takes place. And again, when you're talking about the plant, the morphology and everything, we'll discuss in detail about that. Okay, so this is about the plasticity. Now we move to the when you take even the larkspur, you would have studied about the terrestrial habitat. This example also sometimes I give larkspur. I hope the spelling is correct. Larks, L-A-R-K-S-P-U-R. This larkspur is also an example. This, the difference that you could see in the case of plasticity. Sometimes the question comes, which among the following like plants which shows the plasticity? You gave the options like you see for the buttercup, like Ranunculus fragillaris, the larkspur. These are all the examples. Okay, fine. Now we move to the next. The main important part of this is the plant hormones. So here we go to the second segment of this particular chapter is the plant hormone. Coming to the plant hormone, how the plant hormones can be classified? The plant hormones can classify the natural hormone and the growth hormone. I mean the synthetic hormone. So we have two types of hormones here. The natural. So simply we call it as PGR. PGR is a plant growth regulators, or we call it as a plant hormone. Definitely from this part, juvenile phase is the initial phase actually. Juvenile phase is the initial phase just before the vegetative part. This is a juvenile phase. But the reproductive is an exact phase which is ready for maturation. When it's getting matured, when it's going for reproduction, like that is the phase where you could see actually the maturation phase is the reproductive phase. Okay. Juvenile phase is the vegetative, the initial phase. Okay, before the reproductive phase is called a juvenile phase. Okay. So natural and the synthetic. Coming to the in this part, you can get definite one question, either any of the hormone. Okay, so auxins, gibberellin, cytokinin, ethylene, abscisic acid. So ethylene, out of this five, we have five here. So these out of these five inhibitors are ethylene and abscisic acid. We call it as ABA, abscisic acid, ABA, and auxin, gibberellin, cytokinin. These are all plant growth promoters. And these two are sometimes mostly the questions come from ethylene and abscisic acid. Which among the following is the growth inhibitor? Growth inhibitor, you can search for an option, it is ethylene or abscisic acid. Whereas the plant growth promoters, auxins, gibberellins, or the cytokinins. Fine. So this is how we can classify. There are other way. This is all the natural. Synthetic, for example, from the auxins. Can someone expand? What is NAA? NAA. So chlorosis. Chlorosis is actually the death of the tissue. The death of tissue, we call it as chlorosis. You asked about, right? The chlorosis is actually where the chlorophyll loss is called as chlorosis. And etiolation is not exactly same like the chlorosis. Etiolation is different from the chlorosis. Fine. So NAA. Can someone give expansion for NAA? What does NAA stands for? And what is this 2,4,5-T stands for? These are all synthetic plant growth regulators. In which who first discovered the plant growth regulators? Who first discovered the plant growth regulator? Naphthalene acetic acid is the correct answer for NAA. Naphthalene acetic acid. And who first discovered the plant growth, plant hormones? Because the plant hormones usually what? It's usually the organic compound, and this was proposed by Thiamin. Thiamin was first identified this plant growth regulators in the year 1948. 1948. Okay, right. Both will give the yellowish color to the leaves. Yes, I'm agreeing with both will cause the yellowish color to the leaves. But when you talk about etiolation which gives even which is responsible for the withdrawal of the leaves, in fact. So, but only the chlorosis, which actually loss of only the chlorophyll pigment. But etiolation is a process. It not only reduces the chlorophyll pigment, but also it makes the leaves to follow. It also enhances necrosis, etiolation. In that way, we can differentiate chlorosis and etiolation. Fine. So we move to the next part. That is auxins. The auxins that we'll discuss first. We move to the first part, auxin. Coming to the auxin, we'll start with the first hormone. That is auxin. Who discovered auxin? Auxin is the first plant growth hormone which was discovered, which was the first plant growth regulator that was discovered. The derivative of auxin. Sometimes they ask the question. Auxin is the derivative of what? Auxin is the derivative of indole. Is a derivative of indole, and it's an organic acid, and it is produced in what? Produced mostly in the stem and the root apexes. It's produced in the stem and root apex. Mostly the auxins are apex. Mostly it's present in the stem and the root apex, and this from this area, this will be migrating to the action. So it will be migrating. It will be migrating to the other areas, action regions. So it will migrating to the other region. Okay, but actually it's where it is getting stimulated, where it's in the stem and the root apex, and this auxin is actually synthesized by amino acid tryptophan. This is produced by tryptophan. These two areas we can ask a question like, it's synthesized by tryptophan. It's a derivative of indole. It's a derivative of indole. Fine. So this was first proposed. Auxins was first proposed by Charles Darwin. Charles Darwin and his son. What's the son's name? The Charles Darwin son's name. He and his son, Charles Darwin and his son, both they contributed, and they actually in the year 1800 itself. It occurred in the year 1800. He and his son, Charles Darwin and his son, both actually contributed their efforts in the experiment on oats and the canary grass. They performed on oats and these are like historical perspective. Canary grass. Using this oats plants and the canary grass, they performed this experiment. Charles Darwin and his son. And later part, what happened? The confirmation which was given by confirmation of auxins, which was given by Cole. K-O-A-L. It's K-O-A-L. Okay. Cole and Adam Smith. Confirmation of this auxins, which is given by the study, which was initiated by the Charles Darwin and his son. And later part, this Cole and Adam Smith in the year 1931. In the year 1931, they confirmed by means of performing repeated experiments they performed. Which part? On the coleoptile region. On the coleoptile tips. On the coleoptile tips. Right? You would have studied about experiments like, the gelatin blocks they just cut and, they remove the gelatin blocks. You would have studied the coleoptile experiments. I just show that even the experiment also. By that, you would have seen like, this coleoptile started bending towards like away from the light, Okay, this was actually done. The experiment which was performed by Cole and the Adam Smith issuing the gelatin that blocks, that is with the coleoptile tips. Okay. You're asking about which son? Yeah, he had many sons. So his son, actually, we're talking about Francis Darwin. His son name is Francis. Francis Darwin is his son. Actually, as far as the contribution is concerned, the Charles son Francis, they performed the experiment on the oats and the canary grass. And the Cole and the Adam Smith, they performed with the coleoptile. They done with the coleoptile. And these guys actually, they first isolated auxin. They first isolated auxin from human urine. Isolated auxin from human urine. Urine samples they collected. And from that, they first isolated the auxins from the human urine as well. And the plants are concerned, auxins isolated from the coleoptile tips. In the plants are concerned, the auxins were first isolated from the coleoptile tips only of the oat plants. This was performed on the oat plant. But this experiment which was already performed by the Charles Darwin and his son, but this confirmation was given by the Cole and the Higgins, and they confirmed the auxins are present in the coleoptile and also the isolated auxins from the human urine. This is a little bit of like historical perspectives. And this isolation, there's one more scientist that you could see is actually F.W. Wendt. You may not forget this person. That's the reason, like, always we call like, F.W. Wendt experiment. F1 Wendt experiments usually performed with the agar blocks. I mean, the gelatin blocks, we placed it, and placed in a different area. And it just confirmed the auxins which present only at the coleoptile tips. This confirmation which was performed by F.W. Wendt. Clear? So now we move to the types of auxins. Auxins, we have like, two types of auxin. One is the natural auxin, other one is the artificial auxin. So auxins, this part also you can get a question. So they give an options and they'll ask you to identify the natural auxin or this is an artificial auxin. So When we categorize the natural auxin or the artificial auxin, natural auxin you take indole acetic acid. Indole IAA. IAA stands for indole acetic acid. IBA, PAA. Can you give an expansion for IBA? PAA. These are the expansions. IBA, PAA. Okay. IAA, IBA, PAA, then I3 acetaldehyde. I3 acetaldehyde. I3 acetaldehyde. Acetaldehyde. IPA. IPA. These are all like examples for the natural examples. Let us not worry about like how many kids sons that Charles Darwin has got. It's very simple. His son Francis Darwin contributed in his work. Okay, so we're not going, because this question is not going to come how many children that Charles Darwin has got. Okay, this question definitely will not come in your NEET examination. Fine. Okay, guys. IAA is indole acetic acid. Then IBA. What is IBA? Indole 3-butyric acid. IBA stands for indole 3-butyric acid. PAA. PAA is what? Phenyl acetic acid. Then I3 acetaldehyde. Then I3 IPA is IPA stands for indole 3-propionic acid. Indole 3-propionic acid. Coming to the artificial things that you can see, 2,4-D. 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 So what is the 2,4-D stands for? 2,4-D, phenoxyacetic acid. Phenoxy, 2,4-dichlorophenoxic acid, and NAA, naphthalene acetic acid. So guys, I'm not writing because for that also I'm trying to save the time. So it doesn't mean like I'm ignoring it. So I'm dictated, right? The expansion for all these forms, right? So IAA, IBA, PAA, IPA, and then I3 acetaldehyde. These are all natural auxins. Coming to artificial auxins, 2,4-D. Okay, 2,4-D. 2,4-D, it stands for what? 2,4-D is a 2,4-dichlorophenoxy acetic acid. 2,4-dichlorophenoxy acetic acid. NAA stands for naphthalene acetic acid. 2,4-dichlorophenoxy acetic acid and naphthalene acetic acid for NAA. Okay, fine. If this part they'll ask you questions, options sometimes about the functions, or sometimes they give an option, they'll ask you to identify which among the following is a natural or which is actually the artificial. Okay, synthetic plant growth artificially, because it's also the artificial also which actually we extracted from the plants only. We can also use the synthetic, but sometimes like the natural is also available. Auxin do not comes under synthetic plant growth regulators. Yes, it comes under the synthetic form. Since it comes under the auxin, selectively under the auxins, we're discussing about the synthetic form, artificially. Artificially, we are extracting in an artificial manner, but it's not naturally secreted. No worries. Like you can also include this under the synthetic form because you are extracting. Artificially, you are extracting. It's not naturally produced by the plants. Okay. So this is a classification. Coming to the antioxidants. For example, I want to stop the function of auxin. So can someone tell me like examples for antioxidants? It means it stops or it suppresses the auxin production. So what are the antioxidant techniques? TIBA, PICA. Maybe this may not be knowing it. Can someone tell me? These are all antioxidants. Antioxidants we call it as TIBA, and PICA. 2,4-dichlorophenoxyacetic acid. I told you already. 2,4-dichlorophenoxyacetic acid. Dichloro. It's not trichloro. It's a 2,4-dichlorophenoxyacetic acid. That is expansion for 2,4-D. Okay. Fine. Antioxidants. I just want to suppress the action of auxin. Then I can administer TIBA and PICA. TIBA is a tridobinoxy acid. TIBA stands for tridobinoxy benzoic acid. Tridobenzoic acid. This is tridobenzoic. Guys, since there's no place, I'm writing in the top and repeating it. Tridobenzoic acid. Tridobenzoic acid. It's an expansion for TIBA and PICA. Coming to PICA, p-chlorophenoxy isobutyric acid. P-chlorophenoxy. This is p-chlorophenoxy. So PICA stands for chlorophenoxy isobutyric acid. Chlorophenoxy isobutyric. Guys, if my writing is not clear, I'm dictating it. Okay, you can follow. Chlorophenoxy isobutyric acid. So these two agents are commonly used, and this is called as antioxidants, which used to stop because it's one of the prime hormones, like, this was first discovered hormone, and I want to suppress the action of this particular hormone. Then what I can do is I can administer this way, TABA or PICA. This can suppress the action. This can stop or cease the function of the auxin. So that's the reason we call it as anti-auxin. Anti means against the auxin. Okay. Yes, it is PCIB. Sorry, guys, this is PCIB. I'm sorry, this is PCIB. Guys, please make a correction. This is PCIB. I write in red PCIB. PCIB. Guys, please make a correction. It's PCIB. PCIB stands for p-chlorophenoxyisobutyric acid. Okay. P-chlorophenoxyisobutyric acid. It's an expansion for PCIB. TABA. TABA is triiodobenzoic acid. Triiodobenzoic acid. Triiodobenzoic acid is the expansion for TABA. So if this things comes like, which among the following is an antioxidants, right? So that time you can go with this, either TABA or PCIB. For that only I've just given this information for you. This act against the auxins, right? Coming to the bioassay. What is actually the bioassay techniques? How do you confirm bioassay technique? Bioassay, the technique that we have for all the hormones. As far as auxin is concerned, okay. Why should antioxidants be used to stop plant promotion? So if the plant is keep on growing, like, if the plant keeps on growing, what it takes, even keep on taking the nutrition actually. So so we discuss about the uses and function. The one thing you should understand, too much of anything is good for nothing, right? The same way the growth is detrimental, means it should be freezed at one point of time, except the meristematic tissues. If it keeps on growing, then what happens? It has to be seized actually. So in that areas, what we do is we administer antioxidants. This you understand when means by we talking about the uses and functions of auxins. For that, in that case, we administer antioxidant. Okay, it's not compulsory that you should use antioxidant, but it's going beyond the limit, right? Already the plant, the soil is like struggling with the basic nutrients, but the plants keep on growing, like this, not giving a way for other plants to grow, because it keeps growing and takes all the nutrients from the soil. In that point of time, what happens? We try to stop or cease the auxin production. Fine. Now we'll discuss arena curvature. Bioassay technique. Coming to the bioassay technique, we have the auxin-avena curvature test. Auxin, avena. This time they'll ask this type of test. What type of bioassay technique that you use to confirm the presence of auxin? Maybe the black is not visible. I'll repeat. Auxin-avena curvature test. Auxin-avena curvature test is the test this usually use. This was first proposed by F.W. Wendt. I already told you. F.W. Wendt in the year 1926. In 1926, this person even performed, because he is the one first identified the coleoptile tips has got the auxins, right? This bioassay technique, which was first discovered by F.W. Wendt, the bioassay name is auxin-avena curvature test. Auxin-avena curvature test. We move the next slide. Okay, fine. We move the next part. Auxin-avena curvature test. Okay. We moved this, like, how the auxin-avena curvature test usually performed by F.W. Wendt. F.W. Wendt, the year 1926, he performed this bioassay technique. So he just placed actually, like, the, what is it called? the gelatin blocks, the agar blocks we talk, the agar block. This block was actually which was removed, and this was placed actually. This was placed and just one side of the coleoptile, and he just observed actually. He observed, and what happened? These hormones, like, where this agar blocks which was carrying the auxin hormones, and this blocks the cause bending of the shoot not exposed to the light. So it started bending, like, in a way towards the darkened side and not towards the lightened side. So by this you can confirm the cells on the shaded sides elongated response to the hormone, the red dots and all you could see. These are the cells that you could see which was responded to the hormone, that is the auxin. This curvature test means the coleoptile will start bending towards the darker side, where it just placed this particular agar block which is carrying this particular hormone. This curvature test is actually the bioassay technique by means of the coleoptile tip. By this, he confirmed this is actually present. It present in the coleopter tip. This was a confirmation made by Oxon. I mean, what is it, like FW? When this was performed in 1926. It's performed in 1926. Fine. We move on to the uses. Next, we move on to the uses. Let me not waste your time by giving the more information. Just quick summary I'll give for uses. What are the uses for the Oxon? Can you tell me? It is for root initiation. Root initiation. This is responsible for flowering. Parthenocarpy. You know what is parthenocarpy, right? You know the difference between the parthenocarpy and parthenogenesis, right? So parthenocarpy, yes. Usually the parthenocarpy is by indoor IAA and IBA. Sometimes very specifically they'll ask among which group of auxin which induce the parthenocarpy, then IAA and IBA. Then root initiation. Root initiation is usually by NAA, naphthalene acetic acid, NAA. Then you take flowering. You take flowering is gets 2,4-D. Usually it's by 2,4-D. So parthenocarpy. Then we have herbicides functions. This can be also used as a herbicide. Herbicide function, and this is also used in the prevention of lodging. Prevention of lodging. Lodging which performed by NAA, herbicide by 2,4-D. So these are the main uses of this particular hormone. Fine. Root initiation, flowering, parthenocarpy, herbicide, and the prevention of the lodging. Okay. Especially this herbicide. Can someone tell me like which particular the situation they used actually the herbicide? Where they confirmed like this auxins can also be used as a herbicide. You would have studied about like jungle defoliant. We call it as jungle. Can someone tell me what is jungle defoliant? Defoliant. In that particular situation, which war is that? That specific war we are talking about. That part, that time only, they identified this auxins can be used as an herbicide. That we call it as jungle defoliant. What type of war is that actually? What type of war is that? Fine, guys. So this is jungle, the defoliant. Okay, jungle defoliant. Guys, listen to this. Listen to the session, guys. So the herbicides which was identified, and this particular jungle defoliant, is usually we used to do this actually. So the war we call it as Vietnam War. At the time of the Vietnam War, right? This first the function of this. Okay, the first that we did the herbicide, the jungle defoliant, the Vietnam War at this particular time, the herbicide word was used. This we call it as an Agent Orange. This also sometimes they'll ask Agent Orange. These are the names actually keywords I'm giving. So related with the Agent Orange. Sometimes they'll ask Agent Orange is related with what? Vietnam War, jungle defoliant. These are all related with herbicides, auxins. That is with 2,4-D. Okay, related to this, any questions comes the Vietnam War, jungle defoliant. You can answer for this. This is related with the auxin. It's all the uses. Coming to the functions, guys. You know the functions. I'm not taking your time. You know the functions. It's mainly used for the cell elongation. Then abscission. Abscission. What does abscission means? Can someone tell me what is abscission? The word abscission means. What do you mean by abscission? Abscission. Then apical dominance is very important for auxins. So mostly they ask this question, apical dominance. So lateral branches may not be entertained. The plant which grows increase in size, the terminal parts alone which keeps on increasing. Fine. So apical dominance, often they ask questions from the auxin. So apical dominance is a feature where the plants, for example, if this is a plant, apical dominance means if it keeps on increasing in height actually, this won't be like allowing the lateral buds to progress. So this will keep on increase. So apical dominance is one of the feature of the the feature of this particular auxins, apical dominance. Then xylem differentiation, cell division. Also xylem differentiation and cell division. This is also the important areas that you can find. Okay. So, guys, if you ask for a break, I try to complete just before 5 minutes. Okay, because if I put a break, then it's go for buffering. Then again, it's a problem for us. So let us continue with the session. I just try to wind up before 5 minutes. So I'm not giving you a break. Fine. So xylem differentiation and the cell division and the abscission, the apical dominance, these are the important function. And auxins, which gives the femaleness to the plant. Can someone tell me what is actually the femaleness of the plant? And certain hormones which gives the maleness to the plant. As far as auxins are concerned, auxins which gives femaleness to the plant. So can we somehow differentiate the maleness and the femaleness of the plant? Okay, so we wind up the session by 3:55. 3:55, I'll wind up the session. So femaleness of the plant is again by the auxins. Fine. So these are the uses and the functions of this particular hormone, that is auxin. Next, we move on to the second hormone, gibberellins. Gibberellins we discuss. Coming to the gibberellin, talk about the gibberellin. The second hormone, gibberellin. So where it was discussed the gibberellin hormone, how many gibberellins are present? Coming to the gibberellin, this was first discovered by the Japanese people in Japan. Can you someone tell me like it was identified in the Gibberella fujikuri? So this is all the first identified. It's identified first in Japan and the Gibberella fujikuri. So, and this is responsible, the Gibberella fujikuri is responsible for causing foolish disease. The foolish disease. The name of the disease that we call it is the foolish disease. Okay. Gibberellins, Japan, and Gibberella fujikuri, and this called as a foolish disease. The foolish disease which causes where? In the seedling of rice. This which causes a foolish disease in the seedling of the rice. There you could see this type of disease actually, foolish disease. Fine. And this disease also called as Bacchini disease. Bacchini, B-A-C-K-A-N-A-E, Bacchini disease. Sometimes the questions comes from either from Gibberella fujikuri. This is important area where it is first isolated, Gibberella fujikuri. Or sometimes they'll ask the name of the disease, Bacchini disease. So this area also you can get often questions that you can get. Gibberella fujikuri or the seedling disease, that is a foolish disease that we call it. This otherwise called as Bacchini disease. So far they identified 100 types of gibberellins. So totally we have known so far the 100 types of gibberellins. Like we have gibberellin like G1, we have G2, like we have G3. Like this, we have so many types of the gibberellins. Can you someone tell me which particular gibberellin was first isolated out of this 100 types of gibberellins we have? Which type of gibberellin was first isolated? So that type of questions also which comes this types they give an option G4, G7, G8. Which type of gibberellin was first isolated? So 100 types. And the first they identified is GA3. We call it as GA. GA1, GA2, GA3. The first they identified is a GA3, which was first identified. Okay. GA3 is C19. The formula that you can, chemical formula C19, H26 and O6. This is the formula for GA3. C19, H26 and O3. And it's the first to discover gibberellin. Okay. And who first actually extracted? The scientist is concerned. Extracted. This gibberellin was first extracted. Can someone tell me who first extracted and who first named it? The person who named, right? Two questions of historical perspective. The person who first extracted gibberellin, gibberellic acid, Ga, and who named this actually? This was by Ebuta Samyuki. Ebuta and Samyuki. They first named Ga, gibberellins. Okay, Ebuta and Samyuki. Then who extracted? The person who extracted was Kurosawa. Kurosawa. He is the person first extracted gibberellin. Fine. Kurosawa first extracted, and the person who named is Ebuta and Samyuki. And the precursor is acetyl-CoA. Acetyl-CoA. The precursor where we discussed in the auxins is indole. There here you could see the acetyl-CoA is the precursor, and often you could see the gibberellin in the reproductive parts, and which is having the especially reproductive parts of the plant which have the more concentrations of gibberellin when compared to the other part. Coming to the anti-gibberellins, as the same way we discussed about antioxidants, There are certain anti-functions which perform, which can stop the function of the gibberellins, right? Anti-functions, or you could take, B995. Example, you take B995. This seems to be like, anti-gibberellins, and malic hydroxide. Even the malic hydroxide. This seems to be having a opposite function. It stops the gibberellins. And you take, postpone D. Postpone D. This also like, which causes. So which acts, which stops or suppress the action of this thing, of the gibberellin, anti-gibberellins. Bioassay. So the curvature test that you perform for the auxins, coming to the bioassay of gibberellin. Coming to the bioassay of the gibberellin, it's a dwarf P test, dwarf con test, dwarf P test, dwarf P test, and we have a dwarf con test. These are the common tests that you perform for performing the bioassay. Okay, and P test, con test, and barley endosperm. We have one more assay. We call it as a barley endosperm assay. Barley endosperm assay. These are the techniques by which we can isolate or identify the gibberellins: dwarf P test, dwarf con test, or barley endosperm assay. Fine. So now we move to the next part, that is uses and functions. So I'll just give an outline for uses and functions of the gibberellins. Uses is a fruit growth. The main function of fruit growth, especially you could see in case of grapes, actually the bunch of grape, how the bunch of grape formation is because of the gibberellins. And you could see pomalin. This is also very important in case of pomalin. This enlargement of which fruit? Can someone tell me? Pomalin. Pomalin is a type of the gibberellin that you could see. Which type of plant where you could see which type of fruit? Which type of fruit? Coenzyme A. It's a CoA. CoA. Yeah, acetyl-CoA. Okay, pomalin, which fruit? You're talking about the maleness of the plant, the maleness that you see, like, unisexual flower, bisexual flower, pollen maturity, protogandry, like, the male matures first, the female part matures first. You would have studied about that. Male become receptive, and you studied about actually in the time of pollen pistil interaction that you would have studied, where one part, like, male part would have been like, matured enough. Some area where you could see the female part would have been matured. So substantial, most of the times, like both male and female may not be matured, or a female part would have been hidden inside, male part would have been like, protruding outside. So majority of the pollen related, the male related things which is contributing, that is for the maleness of the plant. The flowering patterns and all, if it is more, it means it is the femaleness of the plant, right? If a pollen germination, anther production, anther enlargement, the theca formation, if this is related with most of the male structures, then that we call it as a maleness of the plant. But female is something like flowering. When you just compare with the maleness and female, where flowering is mostly like an highly could see, that determines the femaleness of the plant. Flowering pattern is not up to the mark in the particular plant, then it is again the maleness of the plant. It's again based on the male and the female reproductive structure, that is pollen and the pistil, and also by the size of the plant. Sometimes the plants may not go beyond the level, the dwarfism that you could see. The dwarfism is like, the semi-dwarf variety. It's like femaleness of the plant. So based on this, we categorized, right? Yeah. Based on this, we categorized whether it's a male or the female disease. Okay. The Beckenet disease actually, it's in 1898. Yeah, fine. Okay. Abhijit, is it okay for you now? Maybe my rate of speech is quite high, so I can reduce it. Fine. Thank you, Abhijit. Fine. So, pomalin, which type of fruit? The enlargement of apple. You could see, especially with the enlargement of apple, this pomalin can be used. Pomalin can be used. Clear. So, pomalin is there. Next, delay in ripening. Delay in ripening. Where about the delay in ripening, especially in case of, guys, you remember this, delay in ripening in case of citrus fruits. Ripening can be delayed by means of gibberellins. And gibberellins can also be used in a malting. You know the malting, right? In enhance starch digestion in brewing industry. In brewing industry, to enhance the starch digestion, this gibberellins can be used. And also like, breaking dormancy. Breaking dormancy means, it means what? It's antagonistic to, there's which hormone is responsible for the dormancy? It's a ABA, right? So breaking dormancy is again a main function of this gibberellins. And elongation of a dwarf that you could see in case of pea plants and maize plants and parthenocarpy, and also this is responsible for substitution of the cold treatment. Substitution of the cold treatment is also one of the main feature. So you would have studied about vernalization, the cold treatment, right? In case the vernalization, the cold treatment is not like, we cannot go with the temperature. You can go with the gibberellins. The gibberellins are the substitution of the cold treatment. It's a optional, I mean, like, the parallel technique that you can have. These are all the main uses of the gibberellins. Functions are concerned. So stem and the leaf growth, stem and leaf growth, gibberellins. Then you could see the bolting. Bolting, example, the beet and the cabbage. Bolting, what do you mean by bolting? Because since I don't have space, I just draw it here. Cabbage and all, you could see, if you could see the cabbage, the internode formation is there, right? You could see the leaf, it's get bolted. It grows like this. Internode elongation, this takes place, right? So how the cabbage, it looked like a mass structure, it gives like the bulky structure. This is because of internode elongation this takes. Okay, this is also the main feature in case that you could see in case of cabbage, in case of the beetroots, right? These are the areas that you could see. This is called as bolting. Guys, I'm using red, B-O-L-T-A-N-G, bolting. Okay, it's a bolting technique. And seed germination and also the sex expression. I told you, like, maleness of the plant, femaleness of the plant. This is also responsible for the sex expression of the plants. These are the main functions are concerned. So when you ask me, like, what is an abscission? Abscission is actually the fall of leaves. We call it as an abscission. Okay. So we're done with the second hormone. Guys, I'm not giving more importance for uses and functions, and just only I'm telling it. Because if I write it on the board again, it will take time for you. I'm trying to save our time. So I'm not writing all the uses and functions. I just given a glance of it. Okay. So your textbook, or finally I give one tabular column. It gives overall consolidation about the uses and functions. So in order to save our time, I'm not writing it on the board, uses and functions. Okay. So only the other parts only I'm writing it on the board, not uses and functions, to save our time. I hope you understand. Fine. We move to the next hormone, that is third hormone. So we're done with auxin, we're done with the gibberellins. Next we move on to cytokinin. Cytokinin. As of now, we have 18 cytokinins are there. We have 100 gibberellins. We have 18 cytokinins are present so far. Okay. 18 cytokinins. This is actually purine derivative. This is a purine. You remember the purine derivative also. Purine, the derivative, here it is for this one, like auxin is indole. Yeah, cytokinin, it is a purine derivative. And this mainly acts on a cell division. It acts on a cell division. Who first identified this cytokinin? Who first discovered? Who discovered? Miller. The person named Miller. Guys, remember all the scientists' name for all the hormones. This hormone was first identified by Miller. Miller in the year 1955. 1955, he first identified this particular hormone. Okay, fine. So purine derivative, and this acts on a cell division. This isolated. When this is actually isolated, this isolated for unripened. This isolated for unripened maize grain. This isolated from unripened maize grain. So what are the uses, main uses when you talk about Slug and Miller? Exactly, Abhijit, you're correct. It is Slug. You given one more. Yeah, Slug and Miller. You can add this person also. Slug and Miller. So unripened maize, it was first identified. Uses. Coming to uses, guys. So what are the main uses? Transport, flowering, and delay in senescence. These are the main uses. Uses of this transport, flowering, and this is also for senescence. Coming to the transport. Okay. Guys, please check actually, because I'm describing following the NEET preparatory books. It's 1955 only. Please do confirm and tell me, because sometimes the benchmark maybe is given in some textbooks, maybe like approval year is maybe given in the other textbooks. Please do confirm. Maybe for this part I just confirm and tell you it's 1954 or 1955. Okay. Okay, fine. Nice. So transport. Coming to the transport is concerned, this is for phloem transport. Which type of transport? Here it is a phloem transport. Then coming to the flowering. Flowering we could see mostly in the lemna and the wolffia. The plants like lemna, wolffia. Lemna and Wolffia. Senescence. Senescence, actually, this effect is called as what? Richmond-Lang effect. Can someone tell me what this effect called? Richmond. Richmond. Can someone tell me what this effect is called? Richmond-Lang effect. This related with which hormone? This is with the cytokinin. That also more specifically with the senescence. Senescence. Okay. So Kavya, you're confirming it's 1954. Okay. Okay. So when we change 1954. Okay, guys, if you confirm that it's 1954, I'll change it to 1954. Okay. If based on your confirmation, I'm changing it. Fine. So senescence, we call it as Richmond. Snook is actually the other person who contributed in identifying the cytokinins, but majority of the textbooks may not given. They given the Miller, but you can add the Slug also. Richmond-Lang effect. Richmond-Lang effect. What do you mean by Richmond-Lang effect? There's a delay in the aging in the process of aging of leaves. Actually, this effect is a delay in the aging of leaves. The process of aging of leaves can be delayed. So this can be, so wither off of the from the plant is actually delay the aging. So senescence is getting delayed here. So this effect is called as Richmond-Lang effect. Okay, fine, guys. So cytokinins, this much of things. And functions. Functions, I told you, very important functions which perform the cell division, and promotes lateral bud in dicot plants. This is also main function. This promotes lateral. If the plant seems to be bushy, right? It's not going very tall. It's very bushy just because of the cytokinins. This increase the lateral buds. This increase the lateral buds. Fine. This other function that you could see the lateral buds in dicot, especially in the dicot plants, and development of chloroplast. Development of chloroplast. This is also the main function. Development of chloroplast. And also the sex determinations. Here the sex determination, this gives the femaleness to the plant. Fine. So we're done with this particular third hormone, cytokinins. We move to the next hormone, that is ethylene. Ethylene. Can someone tell me like any information about ethylene? What type of hormone is this? Ethylene. What type of hormone? So we go with the fourth hormone, ethylene. As far as ethylene is concerned, this is the only gaseous hormone. It's only the gaseous hormone. We call it as. So it's ethylene. It's actually dinitro. Who first actually identified this particular hormone? Can you name the discovered? Who discovered this ethylene? The person who discovered ethylene. Okay. Who discovered ethylene? Okay. Guys, remaining I'm telling again, the year is concerned. It requires a confirmation. So 1954, 1950. It's not definitely. It's not 1961, guys. It's a 1954. It's given in most of the textbook. You also confirming it. By my side, I just confirm it. Either it's a 1954 or 1955. I'll let you know in the next class. Okay. I'll let you know in the next class. Don't worry about the year. I'll confirm by next class. Okay. Fine. Yeah. Denny. Exactly. So here the thing is discovered by the Denny. And before the Denny comes, like, there's one more person, like, Nedjubov, we call it as, like, how many of clear with the Nedjubov? Okay. So, but usually it's a Denny in the year 1901, the year that he first discovered the ethylene, and the derivative is methionine. Methionine, and the person is Denny. Okay, person is Denny. It's a gaseous form. It's the first gaseous hormone, and usually, like, in the commercial product, usually we get this in the form of ethapone. The commercial form, ethapone is the commercial product that usually we get. From this only we get in the gaseous, we convert to the gaseous form. But how we get in the commercial way, the ethylene we get in the commercial way is an the name is a ethapone. Ethapone is a commercial thing that you get. From this you can get convert into the gaseous form. Okay, and coming to this part, the bioassay part is concerned. Triple response test. Bioassay is this triple response test. This is a test that you perform, right? As far as bioassay is concerned. So there are not so many scientists which comes like, and after that you get Croker and all, but first in the name which also goes with the Denny, which is the first person. After that only, like, many other questions which comes. Okay. Yes, gas chromatography. So gas chromatography is a technique by which we can convert the normal liquid form, the ethanophone, which can be converted into the gaseous form, chromatography. By means of chromatography, that is as Rakshita, correct, gas chromatography technique. Because we study the different types of chromatography, right? Distillation, we have, paper, we usually perform the paper chromatography, ion exchange chromatography, right? In which the gas chromatography is a technique, right? Any bioassay. So for cytokinins, the bioassay part, I'm not sure about this part, so that's the reason. But one thing for cytokinins, I think preservation test. We have preservation test for the cytokinin. Guys, for cytokinin, the bioassay is a preservation. So you can add this. Guys, I forgot to tell this. For cytokinin, there's a bioassay technique is called as preservation test. So I think you asked, yeah, Mudasir, thank you for reminding me. For cytokinin, the bioassay test is a preservation test. Okay. So coming to the ethylene, it's a triple response test. Fine. We're done with this part. And uses, when you come to the uses, it's for the fruit ripening. I'm not writing it on the board. I'm just telling fruit ripening, abscission and senescence, and also for breaking dormancy. These are the main uses. Functions, root initiation. Guys, you just listen to it. Okay, that's all. Root initiation, and epinasty. Can you someone tell me what is epinasty? Epinasty is related with this hormone. It is also responsible for epinasty. Can someone tell me what is epinasty? This hormone, the main function of this hormone, ethylene, is responsible for epinasty. It's related with something with the leaves and the flowers. Okay. And functions horizontal growth. It's responsible for horizontal growth. It's also responsible for transverse growth and also flowering in pineapple. This also influences flowering especially in a pineapple, as you said. It also influences pineapple. Okay, it's Nandakumar, you gave the correct answer. Epinasty is the perplexing behavior seen during the floating of the roots of plants. Hats off, Nandakumar. You have given the correct answer. It's the correct definition that you given. Perplexing behavior seen during the floating of the roots, especially with the flowers, usually with the flowers and the leaves. This process is called as drooping of leaves and flowers. This process is called as epinastic. This comes under ethylene, and it also promotes the flowering in the pineapple and also apogeotropism. What is meant by apogeotropism? You would have studied about geotropism, right? Related to the gravity. What do you mean by apogeotropism? Apogeotropism, it means the roots which lack sensitivity to gravity. It means this will not obey with the gravitational force. So, which is not sensitive with the gravity, this particular hormone, this ethylene, this is called as apogeotropism. So, apogeotropism, flowering in pineapple, and epinasty. These are the important areas that you should remember. Okay, as far as this particular, yeah, negative, exactly. Mudasir, you're correct. The negative again. Yeah, you're good. Negative rooting, right? This will not abide with the gravitational force which act against it. So opposite to the geotropism. This we call it as apogeotropism. That is a very sensitive, to the, it's again not so sensitive with the gravitational force. So we're done with the last hormone that we're going to discuss is, we discuss about the fifth one, ABA. ABA stands for abscisic acid. ABA stands for abscisic acid. Coming to abscisic acid, what's a common name that we'll give for abscisic acid? One is the dormant. This dormant can also be called as, what is the other name for a dormant? This abscisic acid, ABA, can be called as a dormant. The other name for the dormant, what is the other name for the dormant? Okay, who first identified? This was first identified by Bennett, Clark, Keffer. And this dormant, this term is given by a person, that is Waring Robbins. Waring Robin is a person who first given the term Robin. This AB is first discovered by the Bennett, Clark, and the Keffer. Okay, so guys, I'm not sure about the year actually, so just find out and tell me what's the year, because if I give the year also, like it's been fluctuating and so on, you please confirm the year so that we can freeze it up. All right, fine. So dormant can be also called a stress hormone. We can call it as a stress hormone. So this dormant was first given by the Waring and Robbins, and this is a derivative. The derivative is a terpene derivative. Abscisic acid is a derivative of terpene. So I given the derivative for all. So recollect the derivative and also the bioassay technique. Okay, the terpene is a derivative for the abscisic acid. Fine. Functions. When you're talking about the functions, very quickly I just summarize the functions here. Yeah. So 1963 to 1964, to be on safer side, given 63 to 64. Okay, I'll take the 1963 to 64. Again, we need to confirm whether it is 1963 or 1964. All right, Rubina, right? You given nine. I'll just confirm the. Let's see, guys. You confirm the 1960. The Rubina, she has given 1963 to 1964. You just confirm again. Okay, Waring and Robin. We just name this hormone as a dormant. Coming to function, this is main function is which increases stomatal closure. Stomatal closure is very important function for abscisic acid is concerned. Okay, so we'll wind up the class by 3:55. I told you like 3:55. We'll wind up the class. Okay, responsible for stomatal closure and bud dormancy. Bud dormancy, abscission, geotrophism in roots, and also this is responsible for synthesizing carotenoids. Carotenoids, and it regulates the fruit drop. It also regulates the fruit drop. It also regulates the fruit drop. And this is the antagonistic to all the growth promoters. Is very important. This is antagonistic. This is antagonistic to all, not growth inhibitors. I'm talking about growth promoters. What are the things that you studied? Yes, for growth promoter. This is no. So this is, the antagonistic. Whatever you studied so far with the growth promoters, like the same thing that you need to mention opposite way, right? That is for apical dominance. Yes, like it is no. So this hormone, abscisic hormone, which acts like antagonistic to all the growth promoter. Okay. Yeah, the dormant is the common name that we are giving actually. The dormant is a name that we're giving for the abscisic acid or the stress hormone that we're giving for this abscisic acid. Usually we call it as a dormant. Okay. Antagonistic in nature. So for all the growth promoters. So we're done with all the hormones. 5 hormones we done, like auxins, gibberellins, cytokinins, abscisic acid. That all the 5 hormones we done. That is growth promoters as well as growth regulators. Okay, guys. So you freezing. It's on 1963. So disclaimer: you given Bala MP. You given us 1963 based on your confirmation. I'm writing on the board. The confirmation is 1963. I hope you're okay with this. Okay, 1963. Disclaimer. So I'm not responsible. So you given correct year, the 1963 as of now. We're freezing it with 1963. Fine. So now next we're done with all the plant growth hormones now. Okay, we're done with all the plant growth hormones we done so far. Okay, now I'll ask you questions like what is the bioassay technique? The bioassay technique that usually we go for this thing actually. This particular hormone. What is the bioassay technique that usually go? Because I given for all the other hormones, you find out and tell me what is the bioassay technique that you should perform. Usually perform for abscisic acid. For this particular thing, what is the bioassay technique? Bioassay technique that you do for abscisic acid. I given for all the 4 hormones, you tell me what is the bioassay acid technique. Is a rice coleoptile. Exactly, it is very good. It is rice. Guys, I really appreciate your attentiveness. Very good. Thanks for your response, guys. So it is rice coleoptile test. Your response is awesome, guys. So thank you so much. Okay, fine. It's a rice coleoptile test that we are confirming it for the bioassay. Next, we're going to do with the seed dormancy. So what is a seed dormancy? The next topic that we are going to discuss is about seed dormancy. By this I can close. The remaining things we can discuss in the next class. Okay. So I close with the seed dormancy. As the seed dormancy is the inactive state of the seed. So what is happening in the seed dormancy? The growth of the embryo. The growth of the embryo, you would have studied how the seed forms when you start about the structure of anatrophous ovule. You study like sudden cell 8 nucleate stage that you would have studied. The one male gamete which goes fused with the egg cell. The other male gametes which goes and fused with the polar nucleus, the secondary nucleus. That is double fertilization takes place. The embryo formation takes place. These things that you would have studied in the development of angiosperms. The that the area would have studied how the embryo forms, and then ovule will become a seed. This is how it was studied in the basic concept. But what the seed dormancy, the ovule had become a seed. Now the seed dormancy, the dormant is something like which is going with the inactive stage, right, during unfavorable conditions. So what is happening in the seed dormancy is that the growth of embryo remains suspended and not resume even in a favorable condition. Mostly this may not be like resuming back even into the favorable condition. So it's getting all the, it's not, doesn't mean like the metabolic function everything get lost. It's all there, but it's going with the dormant stage for some point of time, right? So immediate germination of something that we got it as hypogeal and epigeal. We have two type of germination. So Christian, you said like germination, that also we have two types: hypogeal germination and epigeal germination. So one in case of like monocot, other one in case of dicots. This way difference epigeal and dicot. That's because of like elongation of hypocotyl, and there in case like coleopial and coleorhiza in case of monocot. This differs, make variations in case of monocot as well as in case of dicot plants. Okay, fails to germinate even in suitable conditions. Sometimes like even it go in the dormant stage beyond, even you give the you sow like 100 seeds, like sometimes you may not expect all the 100 seeds germinate. Even you giving the favorable condition, certain seeds which cannot germinate, it means even you provide the favorable conditions, there will be lack of function. So that also which comes under the, you don't come to conclusion if you give the favorable conditions all the seed must grow or germinate. No, certain seeds which not even you provide the favorable conditions, this fail to grow. Okay, so this is a condition where we call it as a, see, there are many factors that we're going to discuss, like what are the factors which are going to confirm, determine what the seed dormancy or the probation of the time span of the seed dormancy. Then we're going to discuss the factors. Coming to this part, so what is the causes of the seed dormancy? First we're going to discuss. So what are the reasons for the seed dormancy? The first reason is like impermeable of the seed coat to the water. So first is seed coat. The main reason is the seed coat. It might be the impermeable. It might be impermeable to what? It may be impermeable to water molecules. This is one of the reason, right? Why it's going to the dormancy stage. Why are they extending its dormancy? Example you take in case of Chenopodium. Example in case this plant you take Chenopodium meliotus. Chenopodium or meliotus, these are like these seeds are actually impermeable to water. Sometimes the seed coat, this is what I take it as. Sometimes it is impermeable to oxygen. Certain plants, the seeds are like impermeable to oxygen. Say like an example, Brassica. Brassica is one variety where the seed coat is impermeable to oxygen. Certain time place where the seed coat is impermeable to certain chemicals. Even if you had a chemicals also, like it seems to be in a dormant stage. There you could see in a xanthium species. Xanthium. This type of like seeds which cannot even help out by means of the chemicals also. This determines, these are the causes. Then it is impermeable to seed coat is impermeable to chemicals. Then there are cases where mechanically it is resistance. Mechanically it is resistant. It is very stubborn. Mechanically it is resistant. This does not mean that if you give a favorable conditions the seed is supposed to germinate, because it is mechanically resistant. You can take in case of Lepidium and Capsella. Lepidium and Capsella. These are the plants where the seed coat is mechanically very stubborn or resistance. And you could see in the dispersed seeds of the barley, it's actually interval. There are certain seeds which requires interval. If you're not giving intervals between the ripening, right, the stages you're not giving the interval. Repeatedly you're trying to germinate, it's not giving interval. It requires intervals for ripening. For example, you take the dispersal seeds of barley and oat. Barley and oat. These type of seeds that requires intervals. This requires an inhibitors. Of course, you said like in a caviar, it is presence of certain inhibitors also. Of course, the inhibitors, if it is prevailing for a long span of time, then under even favorable condition also, like the seeds may not germinate. It's a well-known fact. You cannot expect all the seeds can germinate at one stitch. Okay, so then after the intervals that is required, then also embryo is immature. Along with this, you could see embryo. Sometimes the embryo also seems to be immature. You know how the embryo forms when you go back to the double fertilization. Which part of a ovule, which is embryo sac, is responsible for embryo formation? Your egg or your secondary nucleus? Which part of your embryo sac? I'm talking about the ovule. which part of the embryo sac which is responsible for embryo formation? Either your egg, I mean egg cell, or your polar nuclei or the secondary nucleus. Which part? Now, this embryo is immature at the seed germination. So it is immature. So it's not mature, right? So then definitely you can expect germination. You take it in case of Gingbo. Gingbo. I'm not sure the spelling, but Gingbo. So this embryo seems to be like immature. So these are the causes. Sometimes we want to preserve the seeds. We call it the seed bank, as pollen bank, blood bank. We have different banks where we can preserve the seeds of the plants also. Can you tell me what is the technique by which we can preserve it? So I want to preserve it, of 50 years, 80 years plus. Like I want to preserve this type of seeds. Is very rare species, the plants. Like I just want to preserve for my future purpose or for research purpose or something. I just want to preserve it, right? The technique is called as cryopreservation. So cryopreservation is a thing. So Kavya said it is a polar nuclei which turns to a endosperm which supply nutrients to zygote. So zygote only will become an embryo. So it is not polar nuclei, it is egg. So one male gamete which goes and fuses with the egg. So I hope you guys remember the process, right? Embryo formation. This is embryo sac. You could see the synergids, and this is your egg cell. This is an egg cell. And here you could see 3 antipodals. And center you could see 2 polar nuclei. The pollen tube which brings 2 male gamete, right? This is a double fertilization talking about. So one male gamete which fuse with what? One male gamete which go and fuse with the egg cell. The other male gamete which goes and fuse with the polar nuclei. So this will become endosperm. This will become endosperm. And this will become zygote. Clear, guys? So now the zygote only will become what? Will become a embryo. So its understanding is that the zygote only will become an embryo. Then what is the function of endosperm? Endosperm which provides the necessary nutrients for the growing zygote. Okay, so how the zygote, embryo getting formed? Embryo is getting out formed from this male gamete with the egg cell. That is from the zygote only, not from this one, not from the polar nuclei. Or okay, so that is actually we study separately. So if the embryo is not matured, then cryopreservation is the correct technique. So cryopreservation, what is the temperature that you usually go with the cryopreservation? That you put in the cryo cans. What is the temperature? Usually we call it cryopreservation. Minus 196 degrees centigrade in the liquid nitrogen, right? Minus 196. We just preserve this type of rare seeds and everything. We call it a seed bank. So minus 195 degrees centigrade. Minus 195. Yes, it is in liquid nitrogen. This technique is called as cryopreservation. Then what is lyophilization? Is that both are same or different? Cryopreservation and lyophilization. Lyophilization is also the term. Both are same or different? Lyophilization and cryopreservation. Okay, guys. So we done with this part. We are still more. We discuss about the remaining little 20 or 25 minutes session that we have to complete this chapter. Hopefully we complete maybe in the next class, that is on Monday. We'll try to complete. So meanwhile, we just prepare. What are the test papers that you received? Just keep practicing. If you have any doubts or queries, that you just don't hesitate to ask me. If you need a pictures or any images, do ping me so that I can send across those pictures to me. So thank you guys. So thank you for your patience and so patiently listening to this class. Time is 4. Okay. So I wind up in my clock. It's like 15:57. Okay. So before 3 minutes, I'm winding up. Thank you so much. Gene bank. Yeah, gene bank is also for the preservation. So gene is for especially for the genes that we call about the bioinformatics technique, the genes, where like Human Genome Project will study about the gene banks, where it's not related with the cryopreservation. Okay. Thank you so much, guys. I really appreciate your time and patience. Happy weekend.